Okay. So what we have is where we just kind of ended up with was our last set of threads, and then we just stopped with an M30, and we're going to take it out. Just move that % sign down. Okay, so you might be working off of the simulator, or you might be working off of your laptop. Either way, just make sure that you are using the most current version of your program, and I would do something like this in there, or revision A, something as a stopper so that I know how, because what you don't want to do is you don't want to grab an older version of your program and like you've got it faced and turned, and then you accidentally open up another one and you do the threading in it, and then you do the grooving in it, and then you end up with a whole bunch of stuff that doesn't quite make sense anymore. So just make sure that you know that you are working in the most current version. All right, so I finished my last set of threads, my second set of threads. What do I need to do now?
Z51.
Yeah, so get that thing out of there. I went up to X of 1.6. That's up to about this area right here. And I went to Z of 0.1. I'm going to go ahead and do a Z5, an M01.
Capsule.
Yep. M01. And let me get that in the Z as well. And now I'm going to go ahead and pull up my, yeah, so we're going to be, 404. So I will copy out these lines. I'll probably go ahead and grab these 6 lines. Copy, paste it, and it's going to be 404. And probably going to go way down into my RPM, something like G96 of S300. Get down nice and slow. Just because my grooving that's happening is just a much broader size of tool, so it needs to, it's just going to have a lot more opportunity for chatter as I go through there. Okay, so what would my next move be? Oh, I need to go up to 1.6 and Z at 0.1. Okay, everybody with me up to this point? Okay. So a couple of different routes that I can take. I'm going to freeze this for a second. I could go over to here.
Yep.
I could probably just plunge that down.
G75.
Not even using a G75. I could probably just do a G1 to my diameter and then just bring it out. My problem is, if when I'm in the program I run the part, I start to have chatter or this long stringy chip, I have no chip control over that now. It is what it is. I'll have to stop, reprogram it or edit the program. So I do want to go ahead and keep with that G75 as I'm moving along there. So how far back do I need to go? I'll go ahead and keep with the 1.6.
Z minus 2.125.
2.125, so that one's already there on the print for us. Z minus 2.125. Since it's already dimensioned on that back side. So is that groove is just going to be 125 wide, which is how wide our grooving tool is. Oh, I am locked. Okay. So now, what do I do next? You tell me. G75. What's somebody else? What's my next command for that G75 line?
G1.
Well, it'll be an X.
Oh. So it's X 1.3.
Yes. So we'll go X to our diameter that we're cutting to, 1.3. What else do we need? An I. I is what?
0.05.
Right, and so what does it represent? Pecking, yeah. So that way if I need to make some adjustments there, I can. And then all I need after that is a feed rate, and I'll do something like 3/1000 for my feed rate. Is that all I need on that line? Yeah. Okay, so now after that's done, it's going to return back to 1.6. But if I'm a scaredy cat, and sometimes I am, I might just go G0x 1.6. Just to make sure that after it does the groove, it goes out. All right, next, it gets a little more complicated.
It's always complicated.
So here's what I'm gonna, this would be my goal. That what we are gonna do is we are gonna bring our tool over to here. And then we are gonna feed it diagonally to here to create our chamfer. Okay, so we're actually cutting on the back side of that insert. But before we do that, we've got to come in and put a groove in the same spot where our parting tool is going to go. So it's going to go like this. So my first step, I'm going to come over here. I'm going to bring a groove down to about here. Okay, so that's step 1. I'm going to bring it out. Then I'm going to back up and go to here. This is step 2. So now I've got my edge right on the edge of that chamfer. And then I go down to here, and then 3. So I've got to clear myself out of spot before I can run that tool in there. Otherwise, it's running in at an angle, and it runs into the material behind the insert. So I've got to clear myself out of a little spot in order to do that. Then once I get to that spot, I will part off. Part's done after that. Okay. Let's put our first groove in first. Z minus what?
2.625.
Z minus 2.625. Perfect. Now if I want to, I can go ahead and do G75 and go down to, let's just go to, outside of that thing is 1.5 inches. Our chamfer is 50 thousandths. We got to go down to at least 1.4. So let's go to X 1.4, I 50, F 3. Okay. So that's created our first groove in there to clearance that out. You with me up till this point? We've got to make a little trough or tunnel for that tool to go into as it goes across there diagonally. Now, probably the hardest part is I need to get this tool positioned right here. Where is that edge at? So remember, this is the 0 point of our tool though, right? 2.4? Is that what you're telling me? Okay. John says Z of 2.4. Is that a negative?
Yeah.
Okay.
Who wants to destroy this technology?
It's the 50,000 chamfer, and you take it off both sides, right?
But Z, you only have to move it in the 50.
Okay. So
2.
X you would have to do that. Let me get back up on there. So are you revising yours to 2.5?
Yeah. 2.45.
2.45. Z minus 2.45. So where do we part it off, or where do we just put that groove in? 2.6? 2.625. And so we really want to come back 50 thousandths from that, don't we? 2.575.
No. You get 2.575?
Z minus 2.575.
Of course not that long.
No, hold on.
We're still gonna have to have materials
Yeah,
sticking
true.
out.
What?
Yeah, but your part off tool, you don't want,
Right.
you want the back edge on it, so you don't want the front. I was really bad at explaining that, but you understand.
I do think I know what you're saying. Yeah. So we parted, we want to go to 2.625 to part off, right? That's our 2.5 plus our 1/8 of an inch. So we went in and put our first groove in there. And so all we really need to do is come back 50 thousandths. I think that was John's third answer at 2.575, right? And so that's where we want to be, 2.575. And so that would be this edge is at 2.575. And now this is an 1/8 of an inch smaller than that. So it is 2.450. It's 125 thousandths smaller than that, okay? Our overall part length is 2.5. So the top edge of that 50 thousandths chamfer would be 2.45. You with me?
Yeah.
So I would just tell you, this is something I've watched people do this 15 times. But people who have programmed and run machines for a long time, run one, nope. Running it, nope. You know, and they're like, dang it. So this is because what you're doing is you're flipping from front side cutting to back side cutting, and you can do that on a part off tool because it's square. But even though it creates a great chamfer, and that's what you want to do this in as much of a one operation as you can. It does get a little complicated. So this is a more complicated part. So it's okay to struggle with this one just a little bit. So really, the key thing to remember is that from where you parted or where you put that original groove at it, 2.625, you're just going to come back 50 thousandths from that to catch the back edge of this insert. Okay. So we'll go.
D01 X, so Z01 X 1.6.
Yeah, so I'm going to go, I'm just going to do a quick X and Z move. X 1.6, Z minus 2.4, I'm sorry, 575, 2.575. And then I'm going to do a G1, and I'm going to go down to X of 1.5. Okay, so that puts me right on that corner.
Slow off a little bit.
Yes, sir. Good?
Yeah.
Okay, so I've reached that corner exactly where that is sitting at right now, 2.575, and I've made it all the way down to 1.5. So now since it's a 50 thousandths chamfer, I've got to go down twice that in the diameter, so I've got to go down to 1.4, and I've got to feed at a 45-degree angle, so I need to go X 1.4, Z minus 2.625.
You put in another X.
I did. Okay, so now I created a chamfer with the back side of my tool. At this point, I could do a couple different things. I might do a G0. So just don't type anything. Just I'm going to give you a couple examples. G0 X 1.6. Then I go maybe M3 S300, or I could do switch to a G96 S3. What was I already at? 300. S200, M3. Actually, spindle's already spinning, probably okay there. slow it down just a little bit. If I wanted to go to a standard, a consistent speed, I could either go G97 or I could go M3. So both of those things would change that. So G97 is also constant RPM. Then I could go into G75 and then X minus 30 thousandths, I 0.05, F 0.003. Okay, so this is probably something that I would do is I'm at this point right here. I would then do a rapid move up, move to a slower RPM. Then I would do a grooving cycle, parting cycle all the way down. And then I would go ahead and do a rapid, just as redundancy. I know, put a lot in there.
Just like one way.
Yeah, that's a way. I did a couple different options there. So you could, instead of doing the G97, you could do an M3 there. You could, and probably be even a really good idea at this point. So I'll let you get done, and then I want to show you one more option on doing that.
What's the spindle speed you had for the threading tool? Was it 800?
Probably. Yeah.
Okay.
Let me know when you get done with this part. You done? Or are you just
Running it.
okay. I'm gonna erase this stuff because I don't think you need that. I want to give you an option in here to be able to quickly check your part without stopping everything and then restarting. Because what you want to do, you've got a lot of work in this part, so it'd be a great opportunity now after you do that groove to stop it, check it, and then part it off. So what I might do here is as I get to this 1.6, I may do a Z5 M01. And then I'll just put a whole nother startup line in here. And I know it's redundant because we already did it. But then that way I can run my part, cut that backside chamfer, bring it back, and then start it back up again. I gotta wrap it over.
Yeah, this is just getting
Okay.
more complicated.
It is more complicated. So what I did was I stopped myself. So here was our groove that we put down in here at the end of our chamfer, right? So this is our chamfer. We backed up, then we went all the way to 5 inches, M01 for our optional stop. So we stopped there. I went ahead and put this in here as just a redundant command. It just copied that from beginning. Have our G97 for our spindle at that low RPM. Rapid it back to the place where we're going to part off, and then ran my part off from there. So here's how it'll run. It's gonna run everything and then do this little groove for the back here, then go back to 5 and stop. I can check every single dimension, hit cycle start again, it'll come over, part it off, and then go back and get back out of the way again. The benefit in that is the same that we talked about last time, where we don't have to run the whole part it off, and then be like, oh crap, threads are 2 thousandths oversized. Well, I just scrapped the whole part. Where you could have fixed that instead of having to be like, I need another part, I need another part, I need another part, I need another part. Then you end up with a pile of scrap. You want as many opportunities to fix that part before you part it off. And while it's still in the program, you're not having to stop, restart, go back, find a spot, you know, and restart the program. It's all kind of lineal already set up in there. It's a little more in the programming side, but if you think about it for yourself or an operator, you want to leave as many exit points as they can so that they can stop, check the part, then part the part off. Because that's going to really cut down on how many scrap parts that we end up with. Yep.
Which
What?
part-
Well, where to? There?
So which point of the T404 did you change yours and then just put in that
Yeah,
extra
for the
stuff?
thread.
I added a second T404.
I know, but
At the end.
But did you like change anything from the first T404?
I mean, well, I slowed it down, spindle speed down just a little bit. My part off, I want to go really slow, because what I don't want to have is a piece 2.5 inches long by 1.5 inch diameter come flinging off at, you know, 10,000 RPM or something. I mean, I want that thing to drop nice and slowly for me. That way, if I have a parts catcher or whatever, or if I'm catching it, or if it's just dropping, whatever, you know, there's nothing worse than having a part sling back, hit a chuck jaw, bounce around through there like crazy, and really cause, like, it just gets noisy and nuts. So this right here, the double sets of threads I don't think was that complicated. It was just more than one set of threads. The radius, I think we found that was pretty dang simple. Front side chamfers, not terrible. We've actually decided that we like radiuses a little bit better.
Yeah.
The backside chamfer is probably the hardest part of this part.
I don't know the whole thing.
Can you scroll down a little bit?
Let her get caught up.
For the G76, you go to 2.2.
Yeah, I mean, it's gonna look like something. It may not show like a full-on chamfer. You might,
Shows like a square.
yeah, it probably shows something like,
it up.
it goes down, it goes over, it goes down, then it feeds down like that. So it might be a little kind of a odd looking square. You might need to
Yeah.
zoom way tight into that section.
With thread?
Yeah, don't be afraid to zoom way deep into those sections so that you can see everything that you're doing.
Did you go to? Yeah, I'm good.
What's it look like?
How do you know how far to
I think what-
back on that?
Parts it off. but
That's
it's
gonna be your
like
Z.
fraction.
Yeah, I know.
Okay.
How'd you?
So all I did was take this length and subtract the card control.
This one?
So I took the length here to here and I subtracted the card control. Cause the card control is gonna
Oh,
go in.
yeah, we
and-
got a problem there.
Yeah, just go down to.
Okay,
One
so
inch minus 1.
your first
Or 1 inch.
Your
minus
first
1
groove
inch.
looks fine, but your, I don't know what that is. Oh, tornado,
Which one's that?
yeah.
It's improvement, good job.
Just-
Yeah, I'm gonna pause us.